So today we're going to talk about section 6.6, and this is going to be trapezoids and kites, and then we're also going to include some coordinate proofs like we did in the last lesson. So in your vocabulary that you're going to fill in for trapezoids, you're going to see some body parts. So we're going to talk about the different body parts of a trapezoid. So first of all, the sides that are parallel, like if I extend these lines, these are parallel lines. The sides that are parallel are always called bases. So that's a base and that's a base because those are the parallel sides. The sides that are not parallel to each other are called legs. So that's a leg and that's a leg. The other body part that you'll have in a trapezoid are base angles. So this is a base angle and it is paired with this base angle. Now they're not exactly the same, but they're up against the same base, so that's a pair of base angles. This is a base angle and this is a base angle pair, so that pair goes together in the top because they're up against that base. Alright, so over here we're going to label the same thing. Now notice this trapezoid is the other direction, so my parallels are here. So same idea, this is a base, this is a base, this will be a leg, and this will be a leg. Now the legs do not have to match, but they will in just a second, so sometimes they do and sometimes they don't. And again, you would have base angle pairs. So that would be a pair of base angles, and that would be a pair of base angles. So it says, notice in each trapezoid there are consecutive interior angles. This is because there is one pair of parallel sides. So there'll be two pairs of consecutive interior angles. So let me show you where those are. This base angle and this base angle would be CIAs, and so they are going to be supplementary. So keep in mind you can use that. That's from chapter 3, but we can still use that. And then this base angle and this base angle will also be supplementary because that's a pair of consecutive interior angles. All right, moving on. So a special type of trapezoid that has congruent legs is called an isosceles trapezoid. So you might remember the isosceles triangle, but this is an isosceles trapezoid. So if the legs of a trapezoid are congruent, then it is an isosceles trapezoid. It's kind of like if you take the top part of an isosceles triangle and you cut it off, the bottom part will be an isosceles trapezoid. So we're going to label the parts. So this is a leg, and this is a leg, and the reason those are legs is they are not parallel. The parallel sides are still called the bases, and you still have base angle pairs. But because it's an isosceles trapezoid, you're going to have more things that are true about it than you do if it's just a generic trapezoid. So all of these three properties that we have to do with an isosceles trapezoid. So we're going to talk about them. So first of all, it says if a trapezoid is isosceles, then each pair of blank angles is congruent. So, or blank, I should say. So if you notice, I pre-measured these angles for you. I've got a 132, 132, a 48, and 48. This right here is a pair of base angles. If you notice, they are congruent. This is a different pair of base angles, and if you notice, those are congruent. So it says if a trapezoid is isosceles, which this one is, then each pair of base angles is congruent. That doesn't happen if it's not isosceles. And then it says if a trapezoid has one pair of blank base angles, then it will be isosceles. This is like the converse of this, or it is the converse. You're flipping it around and saying if you know you have a pair of congruent base angles, then you can guarantee that it would be isosceles versus the ones at the top which wouldn't have congruent base angles. All right, so there's one other thing we need to talk about with isosceles trapezoids, and that is going to be the diagonals. So we are going to connect the diagonals in our isosceles trapezoid, and we're going to look at them. This does not happen at the top, but if you look at these diagonals and you measure them, this is about 7.4. This is about 7.4. So a trapezoid is isosceles if and only if its diagonals are congruent. So you can use this theorem either way. You can use it forwards or backwards. The other thing you can say, if you have congruent diagonals, then you have an isosceles trapezoid. As long as it's a trapezoid, it will be isosceles. All right, so taking that idea, those ideas for isosceles trapezoids, we are going to go to page 440 and look at a couple of questions here. All right, so this question, I'm going to turn off this lamp so you can see it a little bit better, is on page 440. And I've marked some of these pictures, or some of the picture for you. So the first thing that I'd like you to do is find XWZ. Okay, so when I look at XWZ, obviously XWZ is going to compare with YZW. So when you look at YZW, I already marked it for you. They told you in here that it was 45. That means since this is an isosceles trapezoid, then that means this angle right here will be 45. So this one is going to be 45, which I'm going to put right into my notes. All right, now I'm going to go back and look at the next one. They would like you to find WXY. Okay, so WXY is this angle up here. Now keep in mind, if this one is 45, these are consecutive interior angles, so they're going to be supplementary. So I'm going to take 180 minus that 45, and I'm going to get what's left, which is 135. So this one we will say is 180 minus the 45, and so we get 135 on that. All right, let's look at C. So C wants XZ. So XZ is this entire diagonal right here. Well, we just learned, if you have an isosceles trapezoid, that your diagonals are congruent. So if this diagonal is 25, this one would have to be 25 as well. So XZ will be 25. And the way we got that is we took the 15 plus the 10 in the picture. And finally, 1D says they would like you to find XV. So let's look at XV. XV is this little piece right here. Well, if this diagonal is the same length as this diagonal, and they're cutting here, if this piece is 10, if this piece is 10 for this one, this piece is going to be 10 here. And again, if this one's 15, this one's 15. So these little pieces at the top match, and these little pieces at the bottom match because they're symmetrical. So XV will end up being 10, just like VY. So we'll say that that is 10. All right, for this year, we are going to skip example 5, just with time. We don't need to cover that. So we are going to flip it over and talk about one other thing with trapezoids. Okay, so I'm going to kind of streamline this a little bit and show you a couple of things that you might notice, which is some of the stuff up here. So the first thing I want to do is I want to connect the two midpoints of my legs. So I'm going to just estimate, and if we had more time we would do this exactly, but I just want you to estimate where the midpoints are, and I want you to connect the legs there. All right, what that does is it makes something called a mid-segment. So we're going to say that when you connect the two midpoints, you form what is known as a mid-segment. All right, so it says to use your protractor, but I kind of pre-measured a few things for you. So if this angle is 80 and I use my protractor, I'm going to notice that this angle is 82. And same thing here, I already measured that one, and this one is the same. So these are corresponding angles, and they are congruent. So by the CA converse, what's going to happen is it's going to make these lines parallel. And then what will happen is, because these lines are parallel and the top is already parallel to the bottom, then all three of them will be parallel. So you would notice that the angles are the same, and then that's going to cause these CAs, since they match, it's going to cause our lines to be parallel. So you would say that the mid-segment is parallel to both bases. All right, next, there's one other thing that you are supposed to notice about the mid-segment. Not only is it parallel to the bases, it has one more property. So I extended and did what it said here. I extended my bottom base out and I added AB to the bottom base. Now, if I measured this mid-segment right here, it is 4 centimeters. This down here, when I added the two bases together, they were 8. So basically, the mid-segment is half the sum of the two bases, because when I add the two bases, I get 8, and the mid-segment is 4. So it says, what are you concluding about the mid-segment and the sum of the bases? What you're going to say is the mid-segment is half the sum of the bases. So that is a mid-segment theorem that we're going to use. So it says the mid-segment of a trapezoid is parallel to both bases, and the measure is 1/2 the sum of the lengths of the bases. And I'm just going to put added together. Okay, so now what I'm going to do is show you a couple of examples. This is going to be on page 442 in the book, I'm just going to show you how you use this midsegment theorem. So in this picture, you're going to see a midsegment, which is connecting the midpoints. So in my picture, I did not tick my pieces, which I'll go back and do, but these are midpoints. So this is tick, tick, double tick, double tick. That's called a midsegment. So watch how they set this up here. They took and they averaged the bases. So they took and added the bases and then took half and set it equal to the midsegment because they knew that the midsegment was 15. So basically, you're going to set this up as 15 equals half the sum of the midsegments, or the sum, sorry, half the sum of the bases. Now you're going to double the 15 to get 30. That will take away the half, and then you're going to subtract 18.2. So this is an example on page 442, and that will kind of show you how you can work with the midsegment. Now, if you go back to your notes, I'm going to go ahead and tick, tick, double tick to show you that that is a midsegment. Okay. All right, so now what's going to happen is we're going to spend just a couple minutes on kites, and then we're going to look at some coordinate proofs to finish out. So when you guys have kites, there aren't a whole lot of things that we have to know about kites, but one thing that we do need to know is what the definition is. So the definition of a kite is it's two sets of congruent sides that are not consecutive or not next to each other. So two pairs of congruent two pairs of congruent, I think I said that wrong, two pairs of congruent consecutive sides. So these sides that are next to each other match, and these sides that are next to each other match also. And then over here, if I was marking this, these two sides match and these two sides match. But they're not, it's not a parallelogram. So I need you to keep in mind that because you don't have parallels and you don't have opposite sides congruent, you will not be a parallelogram. So a kite and trapezoid are not parallelograms. All right, so now what we're going to do is talk about the parallel or the kite properties that are on the next page. So I want you to draw in your diagonals. And the first thing I want you to notice is something that we noticed with a rhombus. The diagonals are perpendicular. So we can use that fact in a kite. The other thing that you can notice is that there is one set of opposite angles that are congruent. So this angle and this angle are actually congruent to each other. This one and this one are not. So over here it would be this angle is congruent to this angle. So we're going to fill that in as our kite properties. If a quadrilateral is a kite, then its diagonals are perpendicular. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So using that idea, I'm going to flip to page 443 and kind of show you an example of a kite. Okay, so let's look at this example B. So when you have a kite, you have right triangles again, just like you did with a rhombus. So what's going to happen in a question like this is they're going to be giving you some pieces of information. So for this, they ask you to find ZY. So ZY is right here. Now I want you to keep in mind that the diagonals of a kite are perpendicular. So if I put right angles in there, then I have a right triangle. So again, just like with the rhombus, we're going to be doing Pythagorean theorem. 8 squared plus 24 squared equals Z squared, or ZY squared, or you could say X. And then you're going to solve, and you are going to simplify your radical. So this would be 8 radical 10. So what I'm going to have you do is after the video, just so we can make this video shorter, I want you to try these two questions on this kite on page 443, and you're going to put those answers right in your notes right here, and then you can check with the answer key. So the last thing I want to look at before we shut down is we are not going to worry about this detail this year because these are things that are more detailed than what we need to worry about for this year. I'm going to show you how I want you to do these by the examples at the bottom. So these are the ones that have to do with the coordinates again. So all of these coordinates we've been building, and these are the examples. I've already put in the slopes, so I did the slopes for you, and I want you to go back and just look at what kind of figure these will be. Okay, so let's look at A. When I do the 4 slopes for all the sides, I notice that these are not parallel, but these are parallel. That means there is one pair of parallel sides. So this is not a parallelogram, and it can't be a kite because kites don't have parallels. So this is a trapezoid. Now, Up here, I'm going to get rid of isosceles trapezoid. You don't have to worry if it's isosceles. I just want you to notice, since it has one pair of parallel sides, that it is a trapezoid. Okay, so let's look at this one. So this one we have -1/2 and -1/2. Those are parallel. We have 2 and 2. Those are parallel. Now we have both sets of opposite sides parallel, so we know it's a parallelogram. But could it be more? It might be a rectangle. So let's look at the corners. The corners are opposite reciprocals in all 4 corners. That means we know it's a rectangle. But could it be more? It might be a rhombus. So here's what you have to do to check for a rhombus, which is new. You have to draw in the diagonals, and you have to do the slopes of the diagonals. So when I look at the diagonals, they are not perpendicular. This is 3/4 and undefined. So it is not a rhombus. Now, if it's not a rhombus, then it can't be a square, because a square has to be a rectangle and a rhombus. So your best answer for this is a rectangle. It is a parallelogram with opposite reciprocal corners. Okay, so we're going to look at 2 more of those, and then you will finish the very last page and try a couple of these. Okay, so the next one I want you to look at is C. And for this one, we're going to look at the top and the bottom, and notice that we've got a 0 and a 0, so the top is parallel to the bottom. And we look at the left and the right, and they are parallel, 4/3, 4/3. So we know it's a parallelogram. Then we look at a corner. Is the corner sets, when you look at them, are they opposite reciprocals? They are not opposite reciprocals, so it cannot be a rectangle. So I know it's not a rectangle. Now I know that I could have a rhombus, because even if I don't have a rectangle, it still could be a rhombus. So I come over and I look at my diagonals. So I do the slopes of the diagonals. So the slope of this diagonal is 1/2, and the slope of this diagonal is -2, and those are opposite reciprocals. They are perpendicular, so it is a rhombus. Now I have to ask myself, is it a square? Well, if it's a rhombus but not a rectangle, there's no way you can be a square. You have to be both to be a square. So the best answer for this one is rhombus. Again, we're doing 6 slopes each time. Okay, last one. On D, the top is parallel to the bottom, 0, 0, undefined, undefined. The left's parallel to the right, so I know it's a parallelogram. Next, I want to see if it's a rectangle. So I look at a corner. These are opposite reciprocals, because that's a horizontal line and this is a vertical line. So it is a rectangle. Next, I want to see if it's a rhombus. So I go to the diagonals. Are these opposite reciprocals? Yes, you did the opposite reciprocal there. So these are perpendicular, so it is a rhombus. So this is what makes it a rhombus. And then finally, since it's a rectangle and a rhombus, then we know that this bad boy has to be a square, because it's a rectangle and a rhombus. So we get rid of these other names and we just call it a square. Alright, so after I shut the video off, you're going to go back and do that kite question, the 2 kite questions that we skipped, which are on page 443. And then I also want you to try these problems down at the bottom on your own. You will need to do 6 slopes, and if you want to share slopes with other people, you can. You'll have to do the 4 sides and the 2 diagonals, and then you're going to decide what you think it is based on what we talked about up here.